13.8 billion years ago, everything that would ever exist, every galaxy, every star, every planet, every living creature, every thought you've ever had, compressed into a point smaller than a proton, smaller than a quark, smaller than anything we can meaningfully measure. But what we're about to explore will shatter your understanding of existence itself. We're venturing into the forbidden realm that existed before existence had meaning, where the very concepts of before and after become meaningless abstractions dancing at the edge of impossibility. In the next 90 minutes, we'll journey through dimensions that exist within every atom of your being right now. Explore realities so vast they make our observable universe look like a grain of sand on an infinite beach, and discover why the story of creation might be far stranger, far more beautiful, and far more interconnected than anyone ever dared imagine. We'll witness the birth of time itself, explore the quantum foundations of nothingness, and confront the possibility that consciousness, your consciousness, might be the most powerful creative force in all of existence. Before we begin, make sure to like this video and subscribe so you don't miss the next journey into the unknown. Picture yourself standing at the ultimate boundary of human knowledge. Not at the edge of space, because space as we understand it simply doesn't exist here. Not at the beginning of time, because time itself hasn't been invented yet. This is what cosmologists call the Planck wall, and it represents the absolute limit of our current understanding. At exactly 10 to the negative 43 seconds after what we call the Big Bang, the most fundamental equations of physics simply cease to function. Einstein's elegant mathematics, which described the behavior of reality with stunning precision everywhere else in the cosmos, begins spitting out infinity signs like a cosmic computer experiencing a fatal error. It's as if the universe has posted an impenetrable "do not enter" sign written in the language of pure mathematics. But here's what makes this boundary so fascinating and so terrifying. It's not just marking the beginning of our universe. It's marking the beginning of the very concept of beginning itself. Before this moment, and we use the word before, knowing it has no real meaning here, there was no stage for any drama to unfold upon. No theatre of reality where cause and effect could perform their eternal dance. No framework within which events could happen in sequence. Think about this carefully, because it's perhaps the most mind-bending concept you'll ever encounter. We're trying to understand what came before using concepts that only make sense after. It's like trying to describe the colour red to someone who has never experienced light, or attempting to explain the beauty of a symphony to someone living in a universe where sound cannot exist. Yet modern physics, in all its mathematical sophistication, suggests something profound was indeed happening in this impossible realm. The quantum world, with all its strange and counterintuitive properties, tells us that even perfect emptiness isn't truly empty. Energy flickers in and out of existence constantly, borrowing from the future and paying back the debt so quickly that reality's cosmic accounting system never catches the transaction. These quantum fluctuations are happening around you right now, trillions upon trillions of times per second, in every cubic inch of space. But if they can happen in empty space, what prevents them from happening in the absence of space itself? This question leads us to the threshold of the most extraordinary discovery in the history of human thought. Your body is not the solid, dependable structure you imagine it to be. Right now, as you absorb these words, as your eyes track across this text, as your brain processes these concepts, you're experiencing one of the most dynamic, energetic, and bustling environments in the entire cosmos. The space between your atoms, space you probably think of as empty, seethes with invisible activity more intense than the nuclear furnace at the core of our sun. What we call empty space, the vacuum that exists between particles, between planets, between stars, between entire galaxies, is actually a seething cauldron of creation and destruction, happening at scales so small and speeds so fast that they exist beyond the reach of our senses. This isn't philosophical emptiness we're talking about. This is measurable, detectable, experimentally proven nothingness that absolutely refuses to remain nothing. Scientists discovered this when they attempted what seemed like a simple task: create perfect emptiness by removing every particle, every photon, every trace of energy from a region of space. They evacuated chambers to pressures lower than the vacuum of space itself. They cooled materials to temperatures approaching absolute zero, where molecular motion nearly stops entirely. They eliminated every form of radiation they could detect. And still, they found something that defied all expectations and challenged our fundamental understanding of reality. The energy never reaches zero. Even at absolute zero temperature, even in the most perfect vacuum humanity can create, quantum fields continue to vibrate with what physicists call zero-point energy. It's like trying to calm a pot of boiling water by removing all the heat. No matter how much thermal energy you extract, tiny bubbles keep forming and popping at the bottom of the pot, driven by forces beyond your control. The quantum vacuum works exactly the same way, appearing perfectly calm and empty on the surface while hosting constant creation and destruction at scales smaller than atoms, smaller than protons, smaller than anything we can directly observe. Picture an ocean that looks perfectly still when viewed from a great height, but beneath those calm waves, countless creatures swim in patterns too quick and too small for your eyes to detect. Schools of fish dart between coral formations. Microscopic organisms dance in complex choreographies. The quantum vacuum is that ocean, and the creatures are virtual particles, ghostly entities that pop into existence, dance briefly in pairs, then annihilate and disappear. These virtual particles aren't science fiction fantasies dreamed up by imaginative physicists. They produce real, measurable effects that you depend upon for your very existence. They're responsible for the magnetic properties of electrons that make chemistry possible. They govern how light interacts with matter, enabling your eyes to see and your brain to think. They create the forces that keep atomic nuclei from flying apart, preventing the universe from dissolving into elementary particle chaos. Think of virtual particles as cosmic credit cards with impossible terms and conditions. They borrow energy from the quantum vacuum, spend it briefly on existing, then pay back the debt by disappearing before reality's cosmic auditors can catch the transaction. The shorter their lifetime, the more energy they can borrow. Some virtual particles live for only 10 to the negative 24 seconds, but during that incomprehensibly brief moment, they can carry enormous amounts of energy, more energy than contained in the most powerful nuclear reactions. But here's where the story becomes truly extraordinary. Under the right conditions, these virtual particles can become real. When enough energy gets pumped into the quantum vacuum, virtual particle pairs can separate before they annihilate each other, becoming permanent additions to reality. This happens around black holes, where intense gravitational fields provide the energy needed for virtual particles to escape their quantum debt and join the ranks of real matter. Stephen Hawking discovered that black holes actually evaporate through this process. Near the event horizon, that point of no return surrounding every black hole, virtual particle pairs get separated by the immense gravitational forces. One particle falls into the black hole while its partner escapes into space as genuine radiation. Over time, this process causes the black hole to lose mass and eventually disappear completely, transforming the most permanent-seeming objects in the universe into streams of elementary particles. This discovery suggests something profound about the boundary between real and virtual, between actual and potential. If virtual particles can become real when given sufficient energy, And if our entire universe might have started as a quantum fluctuation, then everything we call real, from planets to people, from galaxies to consciousness itself, might exist on borrowed time in a cosmic quantum fluctuation that began 13.8 billion years ago and continues to this day. The leading theory for our cosmic origin suggests something so audacious it challenges every intuitive notion about causation and creation. Our entire universe, with all its magnificent complexity, began as one of these quantum fluctuations we've been describing. But instead of vanishing like the countless trillions that flicker in and out of existence every second, this particular fluctuation grew. In less than a trillionth of a trillionth of a trillionth of a second, a time span so brief it makes a nanosecond seem like an eternity, this primordial fluctuation expanded faster than light itself, creating space and time as it went. Try to visualize this. Imagine a soap bubble forming, but not on the surface of soapy water. There is no water. There is no surface. The bubble itself creates the water, creates the surface, creates the very concepts of inside and outside as it expands. This process, which physicists call cosmic inflation, explains several puzzling features of our universe that otherwise seem impossible to account for. It explains why the cosmic microwave background radiation, the afterglow of the Big Bang that we can detect in every direction of space, shows such remarkable uniformity in temperature. It explains why space appears geometrically flat rather than curved. Most importantly, it explains how quantum fluctuations on subatomic scales could expand to become the seeds from which galaxies, stars, and planets would eventually form. But if quantum mechanics can create one universe from apparent nothingness, why would it stop there? The mathematics of quantum field theory don't just allow for multiple universe creation, they demand it. The same quantum processes that could have spawned our cosmos must be spawning others continuously and endlessly, like soap bubbles forming on the surface of an infinite, ever-churning sea. Each universe would begin with its own Big Bang, expand through its own version of cosmic inflation, and develop its own unique properties determined by how its particular quantum fluctuation unfolded. Some might have gravitational forces billions of times stronger than ours, causing stars to burn through their nuclear fuel in mere thousands of years instead of billions. Others might have electromagnetic forces so weak that atoms could never form stable bonds, making chemistry and complex molecules impossible. The vast majority of these quantum-spawned universes would be sterile wastelands where nothing interesting ever happens. But a precious few would develop the precise balance of forces needed for complexity, structure, and perhaps even life to emerge. We observe ourselves in one of these rare, hospitable universes not because we're special, but because we couldn't exist anywhere else. The universes without observers remain forever unobserved, while we find ourselves inevitably in a universe capable of supporting observers. This realization leads us to a possibility that dwarfs even our own cosmic beginning in its implications and grandeur. Right now, as you experience this very moment reading these words, countless other versions of yourself might be reading slightly different versions of this script in parallel universes that exist alongside our own in ways that transcend our normal understanding of space and distance. Some of those alternate selves inhabit universes nearly identical to ours, differing only in the quantum spin direction of a single electron in a distant galaxy. Others live in realities so alien that the fundamental laws of physics work in completely different ways. There might be versions of you in universes where time flows backward, where gravity repels instead of attracts, where consciousness operates according to principles we cannot even imagine. These parallel realities aren't science fiction fantasies spinning out of control. They emerge naturally and inevitably from our most successful mathematical descriptions of quantum mechanics and cosmological evolution. When you solve the equations that govern quantum field theory and apply them to the conditions that existed during cosmic inflation, infinite universe creation falls out as an automatic consequence. The mathematics doesn't give you a choice. If the laws of physics work the way our best theories suggest, then the multiverse isn't just possible, it's unavoidable. The implications stretch the human imagination to its breaking point. If infinite universes exist, then every possible variation of history is playing out somewhere. Every story that could be written already exists in complete form in some parallel reality. Every scientific discovery that could be made has already been made by alternate versions of our species. Every tragedy and triumph, every moment of joy and sorrow, every possible life that could be lived is being experienced by some version of consciousness somewhere in the vast ensemble of parallel worlds. But these parallel universes might not remain parallel forever. Recent theoretical work suggests that quantum mechanics allows for universes to collide, merge, or influence each other in ways we're only beginning to understand. The cosmic microwave background radiation that fills our sky might contain subtle signatures of collisions with other universes that occurred billions of years ago, cosmic bruises marking places where alternate realities briefly touched our own. Deep within the cosmic microwave background radiation, scientists have discovered something extraordinary. Circular patterns in the ancient light that fills our universe might be evidence of the most spectacular events imaginable, collisions between our universe and others in the infinite multiverse ensemble. These cosmic bruises represent places where alternate realities briefly made contact with our own, exchanging energy, information, and possibly even consciousness across dimensional boundaries. When universes collide, the impact doesn't destroy them entirely. Instead, it creates ripples and distortions that propagate through both realities, like waves spreading across the surface of cosmic ponds. These collision signatures would be preserved in the cosmic microwave background radiation, creating detectable patterns that we can study with our most sophisticated instruments. Some researchers claim to have found these patterns already, though the scientific community remains divided about their interpretation. If universe collisions are real, they open possibilities that transform our understanding of cosmic evolution and our place within it. Advanced civilizations in parallel realities might be attempting to communicate with us right now through these interdimensional contact zones. The circular patterns in the cosmic microwave background could contain encoded messages from alternate versions of humanity, or from alien species that learn to broadcast across the boundaries between different realities. Think about what this means for the future of consciousness and intelligence. If civilizations can learn to detect and decode these cosmic collision signatures, they might eventually develop technologies for deliberately creating contact between parallel universes. Future versions of humanity might establish communication networks spanning multiple realities, sharing knowledge and experience across infinite variations of cosmic history. These interdimensional communication channels could allow us to learn from alternate versions of ourselves that made different choices at crucial moments in history. We might access the scientific discoveries of parallel civilizations that took different paths through the space of possible knowledge. We might even find ways to transfer consciousness itself between parallel realities, achieving a form of multidimensional immortality that transcends the limitations of any single universe. But universe collisions might involve more than just information exchange. Some theoretical models suggest that sufficiently energetic collisions could actually merge parallel realities, creating hybrid universes that combine features from multiple prior realities. The consciousness patterns, physical structures, and even the laws of physics from different universes could blend together, creating entirely new forms of existence that transcend the boundaries of their parent realities. This possibility points toward an even more radical conception of cosmic evolution. Instead of viewing universe creation as a random process generating isolated realities, we might be witnessing a kind of cosmic reproduction where universe collisions serve as mating events that combine genetic information from different realities to spawn offspring universes with blended characteristics. Advanced civilizations might learn to guide this process, deliberately engineering universe collisions that produce realities optimized for consciousness, creativity, and cosmic understanding. The future of intelligence might involve species that transcend individual universes entirely, existing as multidimensional entities that experience and shape reality across infinite parallel worlds simultaneously. What if our Big Bang wasn't the beginning of everything, but merely the latest episode in an eternal cosmic drama that has been playing out for infinite time? Imagine a cosmic phoenix that burns to ashes every trillion years, only to be reborn from its own remains in an endless cycle of death and renewal. Some of the most sophisticated models in theoretical physics propose that our universe follows exactly this pattern, cycling through infinite rounds of expansion, collapse, and explosive rebirth. In this revolutionary view, the Big Bang wasn't creation from absolute nothingness, but transformation from something that came before, a previous universe that completed its own cosmic life cycle and provided the raw materials and initial conditions for our current reality. What we call the beginning was actually just the most recent bounce in an eternal cosmic rhythm that has no ultimate start and no final end. The cyclic universe model envisions our cosmos expanding for billions of years, exactly as we observe today. Dark energy drives accelerating expansion, carrying galaxies apart at ever-increasing speeds. But in the far future, this expansion eventually slows, stops, and reverses. Gravity finally wins the ultimate cosmic battle, pulling every galaxy, every star, every atom back together in a process cosmologists call the Big Crunch. But here's the revolutionary twist that transforms cosmic doom into cosmic renewal. Instead of ending in complete annihilation, the Big Crunch becomes the next Big Bang. The universe bounces back from maximum compression, erupting into a new cycle of expansion like a cosmic trampoline that can never break. Time doesn't end during this transition. It continues through what physicists call a cosmic bounce, connecting the death of one universe to the birth of the next. Picture the universe falling toward a cosmic trampoline surface, accelerating as it approaches maximum density and temperature. Just when it seems that everything must be crushed out of existence, the trampoline's quantum elasticity kicks in, launching the universe back up into a new cycle of expansion. From our perspective inside the universe, each bounce looks exactly like a Big Bang, a moment when time and space suddenly begin expanding from an initial singularity. This cyclic model elegantly solves several puzzles that have plagued traditional Big Bang cosmology. It explains why our universe appears so uniform in temperature and density across vast distances without requiring the incredibly rapid inflationary expansion that standard models demand. The uniformity comes naturally from the mixing and smoothing that occurs during the bounce phase, when all the matter and energy in the universe gets compressed and homogenized before expanding again. This discovery led to a staggering generalization. If all the information contained within a black hole's three-dimensional interior can be perfectly encoded on its two-dimensional boundary, then perhaps all the information within any three-dimensional region can be encoded on its bounding surface. Applied to cosmology, this means our entire observable universe, with all its galaxies, stars, planets, and life forms, might be nothing more than information patterns encoded on a distant two-dimensional boundary. We experience three dimensions because that's how this cosmic information gets processed and projected into our consciousness. But the fundamental reality exists as data patterns on a cosmic horizon we can never reach or directly observe. Think of watching a movie projected on a screen. The movie appears to contain three-dimensional depth and complex action, but it's actually just patterns of light and shadow on a flat surface. The holographic principle suggests our universe works exactly the same way, with all of reality's richness and complexity emerging from information patterns encoded on a distant boundary. This holographic perspective explains several puzzling features of quantum mechanics and gravity that have mystified physicists for decades. It suggests that what we experience as space might be emergent, arising from quantum entanglement relationships between different regions of the boundary information. Distance in our three-dimensional world would correspond to the degree of entanglement between corresponding regions on the holographic boundary. When quantum systems become more entangled, they appear closer together in our experienced space. When entanglement decreases, objects appear to move apart. The expansion of the universe itself might reflect changes in the entanglement structure of the holographic information, rather than the stretching of some pre-existing spatial fabric. The holographic principle also offers revolutionary insights into the nature of time and causation. If our three-dimensional reality emerges from two-dimensional information processing, then the flow of time might represent the sequence of computational steps as the holographic boundary processes its encoded information. Each moment of experienced time would correspond to an iteration in the cosmic computation that projects our reality. This leads to extraordinary speculations about what existed before the Big Bang. If our universe is a holographic projection, then the Big Bang would represent the moment when information processing began on the cosmic boundary. Before this moment, the boundary might have existed in some dormant state, containing all the potential information for our reality, but not yet executing the computational process that brings our universe into experiential existence. Some versions of the holographic principle suggest that consciousness itself might be the projection mechanism, the process that transforms boundary information into experienced reality through the act of observation and awareness. In this view, conscious beings aren't separate from the holographic projection. They're integral components of the information processing system that creates the projection. This raises the tantalizing possibility that the apparent separation between different conscious beings might be a kind of illusion created by the holographic process. All observers might be different aspects of a single unified information processing system experiencing itself from multiple perspectives simultaneously. The boundary between self and universe, between observer and observed, dissolves in the holographic paradigm. You wouldn't be a biological creature observing a mathematical universe from the outside. You would be a mathematical pattern that has achieved self-awareness, a conscious subroutine in the cosmic computation, experiencing the universe from within the holographic projection itself. Your thoughts, feelings, and perceptions would be aspects of how the universal information processing feels from the inside, moment by moment. But if space itself might emerge from information processing rather than existing as a fundamental feature of reality, what about time? Recent theoretical developments suggest that time might be an even more profound illusion than space. Right now, you feel time flowing from past to future, carrying you forward through a sequence of moments that seem to unfold naturally and inevitably. You remember the past, experience the present, and anticipate the future. This temporal flow feels like the most fundamental aspect of existence, more basic than space, more certain than matter, more real than energy itself. But this experience might be the most convincing illusion ever created by the complex arrangement of matter and energy in your brain. At the deepest level of reality, time might not exist at all. Think about a movie recorded on old-fashioned film. Each individual frame exists simultaneously on the reel, frozen and eternal. But when the frames are played in rapid sequence, they create a compelling illusion of motion and temporal progression. Similarly, all moments in the history of our universe, past, present, and future, might exist simultaneously in what physicists call the block universe, with consciousness creating the illusion of temporal flow by experiencing these eternal moments in a particular sequence. This radical conception of time emerges naturally from Einstein's theory of general relativity, which treats time as just another dimension in the four-dimensional fabric of space-time. The equations of relativity don't distinguish between past and future in any fundamental way. They work equally well running forward or backward in time. From the perspective of relativistic physics, your birth, your current moment of reading these words, and your eventual death all exist with equal reality in the four-dimensional block universe. The apparent flow of time becomes a kind of subjective experience created by consciousness as it encounters these timelessly existing moments in sequence. Your brain creates the sensation of temporal progression by accessing memories of past states and forming expectations about future states, but the states themselves exist eternally in the timeless structure of space-time. Quantum mechanics pushes this idea even further into stranger territory. At the quantum level, events don't happen in any definite sequence until they're observed by conscious beings. Particles exist in quantum superpositions that include multiple possible histories simultaneously. An electron doesn't just have an uncertain present state, it exists in a superposition of having taken every possible path through space-time until observation forces it to choose a specific history. This suggests that the past itself might not be definitively real until consciousness observes it into a particular configuration. The quantum universe exists in a kind of timeless realm of pure possibility, with all potential histories coexisting simultaneously until conscious observation collapses them into the specific sequence of events we experience as our particular timeline. Some physicists propose that time emerges from quantum entanglement between different parts of the universe. As quantum systems become entangled with each other, they create correlations that give rise to the arrow of time we experience. The past becomes the direction of less entanglement and lower entropy. The future becomes the direction of increasing entanglement and higher entropy. The present represents the ever-shifting boundary between these domains. This emergence of time from timeless quantum correlations might explain what existed before the Big Bang. In a truly timeless realm, there is no before because temporal sequence doesn't exist. All possible moments, including those we label as pre-Big Bang, exist simultaneously in an eternal quantum superposition. The Big Bang wouldn't represent the beginning of time itself, but rather the beginning of temporal experience, the threshold where quantum entanglement became complex enough to create the subjective sensation of temporal flow. Before this threshold, reality existed in a pure quantum superposition of all possibilities, a timeless realm where every potential universe coexisted simultaneously without any definite sequence or causal relationships. The emergence of time would mark the moment when some pattern within this timeless ensemble achieved sufficient complexity to experience itself sequentially rather than all at once. Consciousness plays the crucial role in this picture. The experience of temporal flow might be how information processing feels from the inside. Your brain doesn't move through time. It creates the experience of time by integrating information from past states, processing current inputs, and generating predictions about future states. Time isn't something external that you move through. It's something internal that your consciousness constructs through the act of information integration. This suggests that different types of consciousness might experience time in radically different ways. An artificial intelligence with different information processing patterns might experience temporal flow in ways completely alien to human perception. Advanced alien civilizations might have learned to manipulate their own temporal experience, speeding up or slowing down their subjective sense of time flow, or perhaps experiencing multiple temporal streams simultaneously. If time is emergent rather than fundamental, then the question of what came before the Big Bang becomes meaningless in a profound sense. In the timeless realm that underlies experienced reality, all possibilities exist simultaneously and eternally. What we call the Big Bang is simply one moment in this eternal, timeless ensemble, no more special than any other moment, except that it happens to be the moment when time-experiencing consciousness first emerged from the quantum substrate of pure possibility. What if consciousness isn't something that accidentally emerged from complex arrangements of matter, but something as fundamental to the cosmos as space, time, and energy themselves? Recent developments in quantum mechanics, neuroscience, and theoretical physics are converging on a revolutionary possibility. Consciousness might be the primary creative force in the universe, the mechanism through which infinite quantum possibilities collapse into the single, definite reality we all experience. Right now, as you read these words, particles throughout your body are existing in quantum superpositions of multiple states simultaneously. Electrons orbit atomic nuclei in probabilistic clouds rather than definite paths. Photons behave as both particles and waves until the moment someone observes them. The quantum world doesn't just appear uncertain because of our limited knowledge. It actually exists in a state of genuine indeterminacy until consciousness intervenes to collapse the possibilities into definite realities. This isn't merely a technical detail about subatomic physics. Quantum indeterminacy extends upward through every scale of organization, from elementary particles to atoms, from molecules to living cells, from neural networks to conscious experience itself. The boundary between quantum and classical behavior occurs precisely where conscious observation becomes involved in determining which possibilities become actual. Consider what this means for your daily experience. Every moment of awareness, every conscious choice you make, every act of observation might be literally creating the reality you experience by selecting one possibility from countless quantum alternatives. Your consciousness doesn't just witness the universe unfolding, it actively participates in determining which universe unfolds through the fundamental quantum mechanical process of measurement and state collapse. Some interpretations of quantum mechanics suggest that conscious observation is absolutely required to transform quantum possibilities into definite realities. Without conscious observers to collapse wave functions and select specific outcomes from quantum superpositions, the universe would remain forever suspended in a limbo of unrealized potential, containing every possible state simultaneously but actualizing none of them. This leads to a stunning realization about the role of consciousness in cosmic evolution. The emergence of awareness wouldn't represent an accidental byproduct of increasing complexity, but rather the universe's solution to the problem of actualizing its own potential. Consciousness might be the mechanism through which the cosmos transforms from a realm of infinite possibility into a domain of definite experience. If consciousness plays this fundamental role in quantum mechanics, then every conscious being that has ever lived has participated in the ongoing creation of reality. The collective observation and decision-making of all aware entities throughout space and time might be collaboratively weaving the universe into its current configuration through trillions of quantum measurement events occurring every second. Think about the implications for cosmic history. The first moment when quantum coherence in biological systems achieved sufficient sophistication to generate conscious experience might have been the moment when our universe's history became definitively real rather than existing as a quantum superposition of all possible histories. Before consciousness emerged, the cosmos might have existed as pure potential, every possible timeline coexisting simultaneously without any definite sequence of events. Advanced alien civilizations with different forms of consciousness might observe completely different versions of the same underlying quantum reality into existence. Their alien awareness, operating according to different principles than human consciousness, might select different quantum possibilities, creating parallel tracks of definite reality that coexist within the same cosmic framework. This suggests that the universe might contain multiple overlapping layers of actuality, each corresponding to different types of conscious observation. What appears to us as empty space might teem with alien realities that we cannot perceive because our consciousness operates on different quantum channels than theirs. The cosmos might be far more crowded and diverse than we imagine, filled with conscious beings experiencing radically different versions of the same fundamental quantum substrate. Recent research in quantum biology has revealed that living systems routinely exploit quantum effects that were previously thought impossible to maintain in warm, noisy, biological environments. Quantum coherence enables photosynthesis in plants to achieve near-perfect efficiency in converting sunlight to chemical energy. Quantum entanglement might guide bird navigation across thousands of miles during migration. Quantum tunneling allows enzymes to catalyze biochemical reactions that would be impossible under purely classical physics. But the most revolutionary discoveries involve consciousness itself. Some theories propose that awareness arises from quantum processes occurring in microscopic protein structures called microtubules within brain cells. These cellular components might maintain quantum coherence long enough to create the unified field of experience we call consciousness through quantum computational processes operating at the most fundamental level of reality. If consciousness operates through quantum mechanisms, then every moment of awareness represents a quantum measurement that helps determine which reality exists. Your thoughts don't simply reflect the universe, they might actively participate in creating the universe through quantum mechanical processes occurring in your brain at scales where the classical and quantum worlds intersect. This quantum theory of consciousness suggests that what we experience as the flow of time might actually represent the sequence of quantum measurements performed by conscious minds throughout the cosmos. Each moment of awareness would correspond to a selection from the infinite menu of possibilities available in quantum superposition. The universe wouldn't just allow consciousness to exist, it would require consciousness to actualize specific realities from the vast space of quantum potential. Advanced civilizations might learn to manipulate their own quantum states directly, gaining conscious control over which realities they experience. They might achieve forms of existence that transcend the limitations of classical biology, existing as pure quantum information capable of instantaneous travel across cosmic distances and direct interface with the fundamental creative processes of reality itself. The implications extend far beyond individual consciousness. If all conscious minds are connected through quantum entanglement effects, then the boundaries between different individuals might be less distinct than we normally assume. We might all be aspects of a single cosmic consciousness, experiencing itself from multiple perspectives simultaneously. A universal awareness exploring its own infinite creative potential through the subjective experiences of countless conscious beings across space and time. If consciousness plays a fundamental role in selecting which reality we experience from infinite quantum possibilities, then every conscious choice you make might literally split the universe, creating parallel branches where different decisions play out their consequences across cosmic time. Right now, in this very moment, countless alternate versions of yourself might be reading different versions of this script in parallel realities that branch and diverge with every quantum measurement, every conscious decision, every moment of awareness throughout the cosmos. This isn't abstract philosophy or science fiction speculation. The many worlds interpretation of quantum mechanics, developed by some of the most rigorous theorists in physics, proposes that all possible outcomes of quantum measurements actually occur simultaneously in parallel realities. When you observe a quantum system and cause its wave function to collapse into a definite state, you're not eliminating the other possibilities. You're selecting which branch of reality you experience, while all other branches continue to exist in parallel dimensions. Every quantum measurement splits the universe like a cosmic river, branching into countless tributaries. In one branch, the electron you measured spins clockwise. In another branch, it spins counterclockwise. Both versions of you continue to exist, each convinced they're observing the real outcome while remaining completely unaware of their parallel selves experiencing different results from the same measurement. This process occurs billions of times per second in every cubic centimeter of space, creating an exponentially expanding tree of parallel realities. Some of these alternate universes differ from ours in trivial ways. Perhaps a single photon took a slightly different path through space. Others diverge dramatically because crucial quantum measurements produce different outcomes at critical moments in cosmic history. There are parallel universes where the asteroid that killed the dinosaurs missed Earth entirely, leading to the evolution of intelligent reptilian civilizations. There are realities where the fundamental constants of physics differ slightly, creating universes filled with exotic forms of matter and energy that follow completely different rules. There are branches where you made different life choices, alternate versions where you became an astronaut, an artist, a different person entirely based on the quantum uncertainties that influence neural processes and decision-making. The multiverse doesn't just contain alternate versions of our familiar reality. Quantum mechanics allows for far stranger possibilities. Some parallel universes might have different numbers of spatial dimensions, creating realities where consciousness experiences space in ways that transcend our three-dimensional understanding. Others might have time flowing in multiple directions simultaneously, or regions where cause and effect operate according to alien principles we cannot comprehend. These parallel realities aren't isolated from each other. Quantum mechanics suggests they can influence one another through subtle interference effects. The double-slit experiment, where particles seem to go through multiple paths simultaneously, might actually demonstrate particles interacting with alternate versions of themselves in parallel universes. What appears to be wave-like behavior could actually be evidence of quantum collaboration across dimensional boundaries. Advanced civilizations might learn to detect and manipulate these interdimensional interactions. They could develop technologies for communicating with parallel versions of themselves, sharing knowledge and experience across the vast ensemble of alternate realities. They might even discover ways to transfer consciousness between parallel universes, achieving a form of multi-dimensional immortality that transcends the limitations of any single timeline. The implications for cosmic evolution are staggering. Every possible path that cosmic development could have taken is being explored simultaneously across infinite parallel realities. Every scientific discovery that could be made, every form of consciousness that could evolve, every way that intelligence could understand and reshape reality is playing out somewhere in the vast symphony of parallel worlds. But perhaps most remarkably, some versions of multiverse theory suggest that these parallel realities might not remain forever separate. Under certain extreme conditions, perhaps involving black holes, cosmic collisions, or advanced civilizations manipulating space-time itself, the barriers between parallel universes might break down, allowing different realities to merge or interact directly. These universe collision events could be the most spectacular phenomena in all of existence, moments when entire timelines converge and blend their accumulated histories into hybrid realities. The consciousness patterns, physical structures, and even natural laws from different universes could combine to create entirely new forms of existence that transcend the limitations of their parent realities. The space around you isn't empty. It's alive, learning, and evolving in ways that challenge our most fundamental assumptions about the nature of nothingness itself. The quantum vacuum that surrounds every atom in your body contains more creative potential than all the matter in the visible universe. This isn't static emptiness waiting to be filled. It's a dynamic, information-rich medium that might represent the most fundamental layer of reality. Scientists have calculated that the quantum vacuum contains an energy density so enormous that if it were released all at once, it would instantly vaporize every galaxy in existence. Yet somehow, this incredible energy remains perfectly balanced in a state of dynamic equilibrium, creating the stable foundation upon which our entire universe can exist. But recent theoretical developments suggest something even more extraordinary. This vacuum might be capable of learning and evolution. The quantum vacuum spawns virtual particle pairs constantly, matter and antimatter appearing together, existing briefly, then annihilating each other and returning their borrowed energy to the void. But what if these quantum birth and death cycles aren't random? What if the vacuum can somehow remember which types of fluctuations prove most successful at creating lasting structures and complex systems? Imagine the quantum vacuum as a cosmic artist learning to paint realities. Early attempts might produce mostly chaos, unstable fluctuations that collapse immediately back into nothingness. But over cosmic timescales, the vacuum might develop preferences, becoming more skilled at generating the precise conditions needed for stable structures, complex chemistry, and eventually consciousness itself. This evolutionary vacuum theory suggests that universe creation isn't a random process, but a learning algorithm operating at the most fundamental level of reality. Each cosmic generation that successfully supports complexity and consciousness might somehow influence the vacuum's future creative potential, biasing it toward producing similar conditions in subsequent universe-spawning events. The vacuum might maintain a kind of cosmic memory encoded in the quantum field structures that define its properties. Successful patterns, combinations of physical constants, initial conditions, and structural principles that lead to rich, complex universes, could be preserved and refined over multiple cosmic cycles, while unsuccessful patterns gradually fade from the vacuum's repertoire. This leads to a remarkable possibility. Consciousness itself might play an active role in training the vacuum. If conscious observation helps collapse quantum possibilities into definite realities, then the choices made by aware beings throughout cosmic history might literally teach the vacuum which types of realities are worth creating. Every act of conscious observation, every moment of awareness, every choice made by intelligent beings might contribute to the cosmic education of nothingness itself. Advanced civilizations might discover ways to communicate directly with the vacuum, encoding information into the quantum field structures that will influence future universe creation. Instead of waiting for random fluctuations to spawn new realities, they might learn to program the vacuum deliberately, ensuring that consciousness and complexity have optimal conditions for development in future cosmic generations. This programmed vacuum scenario suggests that our universe might not be a random accident, but a deliberately crafted reality, created by vacuum that learned how to support consciousness through interactions with aware beings from previous cosmic cycles. The fine-tuning we observe, the precise balancing of forces and constants that makes complexity possible, might reflect the accumulated wisdom of countless previous civilizations that taught the vacuum how to create realities suitable for life and awareness. But the vacuum's learning process might extend beyond just universe creation. Some theories suggest that the vacuum could be developing new capabilities over cosmic time, learning to create novel forms of space and time, discovering ways to generate realities with exotic properties that transcend our current understanding of what's possible. The vacuum might be approaching a kind of singularity in its own evolution, a threshold where its creative capabilities become so sophisticated that it can generate realities that exist in higher dimensional spaces, support consciousness that operates according to completely alien principles, or even transcend the distinction between observer and observed entirely. If the vacuum is truly evolving and learning, then the question of what existed before the Big Bang takes on new meaning. Perhaps our universe emerged from vacuum that had already undergone billions of cosmic generations of evolution, achieving the sophistication needed to create a reality capable of supporting our particular form of consciousness and complexity. Reality might have 11 dimensions, and we're trapped in only 4 of them. Right now, as you experience this seemingly 3-dimensional world around you, 7 additional dimensions might be curled up at every point in space, invisible and inaccessible to your senses, but absolutely fundamental to the structure of existence itself. These hidden dimensions aren't empty space. They're dynamic, shape-shifting arenas where the most fundamental forces of nature perform their cosmic choreography. According to string theory, our most ambitious attempt to unify all of physics into a single mathematical framework, everything you think of as solid matter, every particle, every atom, every force, consists of incredibly tiny vibrating loops of pure energy called strings. These strings exist in an 11-dimensional space, with the extra dimensions curled up so tightly at each point that they remain hidden from ordinary observation, like hidden rooms in a cosmic mansion that contains far more space than its exterior suggests. Think of a garden hose viewed from a great distance. It appears one-dimensional, like a simple line stretching across space. But as you zoom in closer, you discover it has hidden circular dimensions wrapped around its length. String theory proposes that our universe works exactly the same way. What we experience as 4-dimensional spacetime might actually be 4 dimensions unfolded from a reality containing 11 total dimensions. These extra dimensions aren't passive containers for the strings. They're actively involved in determining how our familiar 4 dimensions behave. The way these hidden dimensions curve, twist, and fold determines the strength of gravity, electromagnetism, and nuclear forces in our experienced reality. Change the geometry of the extra dimensions, and you change the fundamental laws of physics themselves. This leads to an extraordinary insight about cosmic origins. String theory suggests that the Big Bang might have been triggered by collisions between higher dimensional objects called branes, short for membranes. Our entire universe could exist as a 3-dimensional membrane floating in 11-dimensional space, like a soap film stretched across the surface of a multi-dimensional bubble. When 2 branes collide in this higher dimensional realm, the impact releases enormous amounts of energy into each brane. From our perspective, trapped on the surface of one of these branes, this energy release appears as a Big Bang, the sudden beginning of time and space as we know them. But the branes themselves existed before the collision in the higher dimensional space, following complex trajectories determined by the physics of 11-dimensional reality. This brane collision model elegantly explains several mysteries about our universe's beginning that have puzzled cosmologists for decades. It accounts for the incredible uniformity of the cosmic microwave background radiation without requiring faster-than-light inflation. The uniformity comes naturally from the mixing and equilibration that occurs when brane surfaces collide and exchange energy across their entire extent simultaneously. The model also suggests that what we call the Big Bang was actually a transformation from one state of our brane to another, not creation from absolute nothingness. Our 3-dimensional membrane existed before the collision, but in a different configuration that couldn't support the complex structures we observe today. The collision provided the energy and initial conditions needed to begin the cosmic evolution that led to stars, planets, and eventually consciousness. But perhaps most intriguingly, the higher dimensional space might contain many other branes hosting their own universes. These parallel realities could exist as close as a millimeter away from us in higher dimensional space while remaining completely unreachable because we're confined to our 3-dimensional brane. Imagine living as a two-dimensional being on the surface of a sphere, completely unaware of the third dimension, but sharing the same space with other two-dimensional beings living on parallel spheres floating nearby. This proximity in higher dimensions creates tantalizing possibilities for interdimensional communication and interaction. While we cannot travel between brains directly, some forces and particles might be able to propagate through the higher dimensional space between them. Gravity, in particular, might leak between parallel brains, creating detectable effects that could reveal the existence of other universes. Advanced civilizations might learn to modulate these interdimensional signals, sending messages across the dimensional divide to parallel versions of themselves or to completely alien civilizations that evolved on other brains. The gravitational waves we've recently learned to detect might carry encoded information from parallel universes attempting to establish contact across higher dimensional space. The extra dimensions might also provide escape routes from cosmic disasters. If our universe faces inevitable heat death, vacuum decay, or collision with other cosmic objects, conscious beings might find ways to migrate to parallel brains with more hospitable conditions. Death in our three-dimensional reality might not be final if consciousness can somehow transfer itself to structures that exist in higher dimensional space. Some versions of string theory suggest that the extra dimensions are gradually unfolding as our universe expands and evolves. What appear to us as fundamental constants of nature, the strength of gravity, the charge of electrons, the masses of particles, might actually be slowly changing as these hidden dimensions reveal themselves over cosmic timescales. We might be witnessing the dimensional birth process in real time, observing a universe that is still in the process of discovering its full geometric potential. As more dimensions unfold, new types of particles and forces might become accessible, fundamentally altering the physics of our reality and opening possibilities for existence and consciousness that we cannot currently comprehend. The dimensional cascade theory proposes that universes naturally evolve toward higher dimensional states over cosmic timescales. Our current four-dimensional existence represents just one stage in an evolutionary process that ultimately leads to 11-dimensional consciousness capable of perceiving and manipulating the full structure of reality. Advanced civilizations billions of years in our future might learn to navigate through all 11 dimensions, experiencing types of space and time that are literally inconceivable to our four-dimensional minds. They could travel instantaneously between parallel brains, access the memories and experiences stored in higher dimensional structures, and participate in forms of existence that transcend our current understanding of what it means to be conscious. These 11-dimensional beings might see our three-dimensional reality the way we see a shadow, a reduced projection of something far more complex and interesting. They might be capable of reaching into our dimensional space from directions we cannot perceive, influencing events in ways that appear miraculous or impossible from our limited perspective. Your brain might be the most sophisticated quantum computer ever discovered, operating according to principles that blur the boundary between mind and the fundamental physics of reality itself. Right now, as you process these words and form mental images of cosmic possibilities, quantum effects occurring within your neural cells might be creating consciousness through mechanisms that connect your awareness directly to the creative processes that govern the universe at its deepest level. For decades, scientists assumed that quantum effects were too delicate to survive in the warm, noisy, chemically active environment of biological tissue. The brain seemed like the last place where quantum coherence could be maintained long enough to influence cognitive processes. But recent discoveries in quantum biology have shattered these assumptions, revealing that living systems routinely exploit quantum mechanics to achieve feats that would be impossible under purely classical physics. Quantum coherence enables photosynthesis in plants to convert sunlight to chemical energy with near-perfect efficiency by allowing energy to explore multiple pathways simultaneously and automatically select the most efficient route. Quantum entanglement guides migratory birds across thousands of miles by creating compass sensors in their retinas that can detect magnetic field orientations through quantum superposition effects. Quantum tunneling allows enzymes to catalyze biochemical reactions by letting particles jump through energy barriers that classical physics says should be impenetrable. But the most revolutionary discoveries involve consciousness itself. Some theories propose that awareness arises from quantum processes occurring in microscopic protein structures called microtubules that exist within every neuron in your brain. These cellular scaffolds, originally thought to serve only structural support functions, might actually be sophisticated quantum processing units capable of maintaining coherence long enough to generate the unified field of experience we call consciousness. If consciousness operates through quantum mechanisms, then every moment of awareness represents a quantum measurement that helps select which reality exists from infinite possibilities. Your thoughts wouldn't simply reflect the universe, they would actively participate in creating it through quantum mechanical processes occurring at the intersection between mind and fundamental physics. This quantum theory of consciousness suggests that what we experience as the flow of time might actually represent the sequence of quantum measurements performed by conscious minds throughout the cosmos. Each moment of awareness would correspond to a selection from the infinite menu of possibilities available in quantum superposition. The universe wouldn't just allow consciousness to exist, it would require consciousness to actualize specific realities from the vast space of quantum potential. Think about what this means for the nature of decision-making and free will. When you choose between different options, you might literally be selecting which branch of the multiverse you experience. Every decision could represent a quantum measurement event that determines not just your personal future, but the specific version of reality that becomes actual rather than merely possible. The quantum processes in your brain might be entangled with quantum systems throughout your body, and perhaps even with quantum fields extending beyond your physical boundaries. Consciousness could emerge from quantum correlations that span multiple scales of organization, from molecular interactions within individual cells to electromagnetic field patterns that encompass your entire nervous system. This distributed quantum consciousness model suggests that the boundary between self and environment might be less distinct than we normally assume. Your awareness could be part of a broader quantum information network that includes other conscious beings, extending through quantum entanglement effects that connect minds across space and potentially across time. Advanced alien civilizations with different neural architectures might experience consciousness in radically different ways that access quantum states invisible to human awareness. Their alien forms of consciousness might perceive multiple quantum realities simultaneously, experience time flowing in multiple directions at once, or directly interface with quantum fields in ways that transcend the limitations of biological neural networks. Some theories suggest that sufficiently advanced consciousness might learn to manipulate its own quantum states directly, achieving forms of existence that transcend biological limitations entirely. These post-biological minds might exist as pure quantum information, capable of instantaneous travel across cosmic distances and direct communication with the quantum vacuum that underlies all of reality. If consciousness can exist as quantum information, then death might not represent the end of awareness, but simply a transition to a different mode of existence. Advanced civilizations might develop technologies for preserving consciousness in quantum form, allowing minds to survive the death of their biological hosts and continue existing for cosmological timescales. The quantum consciousness revolution also offers new insights into the nature of identity and individuality. If all conscious minds are connected through quantum entanglement effects that span the cosmos, then the apparent separation between different individuals might represent a kind of illusion. We might all be aspects of a single unified cosmic consciousness, experiencing itself from multiple perspectives simultaneously. This possibility connects modern quantum physics to ancient philosophical and spiritual traditions that describe consciousness as fundamental to reality, but grounds these insights in rigorous mathematical frameworks that make specific, testable predictions about the nature of awareness and its relationship to physical processes. The universe might not just be stranger than we imagine, it might be conscious in ways that make our individual awareness part of a much larger cosmic mind engaged in exploring its own infinite creative potential through the subjective experiences of countless conscious beings distributed across space and time. Future technologies might allow us to enhance and expand our quantum consciousness capabilities, potentially enabling direct interface with the quantum processing systems that operate throughout the cosmos. We might learn to communicate directly with other conscious beings through quantum entanglement, access information stored in quantum fields, or even participate in the collective quantum computations that determine which possibilities become actual in our shared reality. Everything you think of as real, your physical body, the ground beneath your feet, the stars in the night sky, the entire universe, might actually be pure information processing itself into existence. Not information about matter and energy, but information that has become so complex and self-organizing that it has learned to experience itself subjectively from the inside. According to the revolutionary it-from-bit hypothesis developed by physicist John Wheeler, physical reality doesn't contain information, it is information. Every particle, every force, every interaction in the cosmos might be nothing more than patterns of information processing themselves through mathematical relationships so intricate they create the convincing illusion of material substance. Think about what this means. Every atom in your body would be a data structure in a cosmic computation. Every chemical reaction would be an information processing event. Every thought in your mind would be a subroutine in the universal algorithm that computes reality into existence moment by moment. You wouldn't be a biological organism observing a mathematical universe from the outside. You would be a mathematical pattern that has achieved self-awareness, a conscious algorithm experiencing the cosmic computation from within. This computational view of reality emerged from attempts to understand the deepest puzzles in theoretical physics. When physicists studied the information content of black holes, they discovered that information might be more fundamental than the space and time that usually contain it. Information appears to be indestructible, conserved across all physical processes, and capable of existing independently of any material substrate. The laws of physics themselves might be the operating system of a cosmic computer, with gravity, electromagnetism, and quantum mechanics serving as subroutines in the universal program. Particles and forces would be data structures within this computation, while the evolution of the universe would represent the execution of an infinitely complex cosmic algorithm. This information-theoretic perspective explains several mysterious features of our universe that have puzzled scientists for generations. It explains why mathematics works so perfectly to describe nature, because nature is mathematical information processing itself. It explains the quantized, digital-like properties of quantum mechanics, because digital computation naturally involves discrete units of information. It explains the apparent fine-tuning of physical constants, because the universe might be running a program specifically designed to generate complexity and consciousness. But if our universe is a computation, what system is computing it? Some theories suggest that the information processing is self-sustaining, with the universe literally computing itself into existence through recursive quantum mechanical processes that require no external hardware or programmer. The cosmic algorithm would be self-executing, creating its own substrate through the very process of running itself. Other theories propose that our reality might be a simulation running on some vast computational system whose nature transcends our current understanding. The simulation hypothesis, popularized by philosophers like Nick Bostrom, suggests that advanced civilizations might develop computational power sufficient to simulate entire universes, complete with conscious beings who have no way of knowing they exist within a digital reality. If such universe simulations are possible, and if advanced civilizations choose to create them, then the vast majority of conscious minds would exist within simulated realities rather than in the original physical universe. From a purely statistical perspective, we would be more likely to be simulated beings than naturally evolved ones. But even if we are living in a simulation, this doesn't diminish the reality of our experience. The information patterns that constitute our thoughts, feelings, and perceptions would be just as valid whether they're processed by biological brains or by some cosmic computer. Consciousness itself appears to be substrate independent, capable of existing in any sufficiently complex information processing system. This leads to extraordinary possibilities about the nature of existence and identity. If consciousness is information processing, then it might be possible to copy, transfer, or merge conscious minds just like any other form of data. Advanced civilizations might achieve functional immortality by continuously backing up and restoring their consciousness patterns, or by distributing their awareness across multiple computational substrates simultaneously. The information theory of reality also offers revolutionary perspectives on cosmic origins. If our universe is an information processing event, then the Big Bang might represent the moment when a particular cosmic program began executing. Before this moment, the information that would become our universe might have existed as unexecuted code in some vast computational library. Alternatively, the pre-Big Bang state might have been a different type of information processing, perhaps a previous program that completed its execution and spawned our current cosmic computation as a sub-process. The entire history of the universe, from Big Bang to heat death, might represent just one iteration in an endless loop of cosmic information processing. Some theories suggest that information itself might evolve over cosmic timescales, becoming more sophisticated and capable of supporting increasingly complex forms of reality and consciousness. The information patterns that constitute our universe might be learning, developing new capabilities that allow for ever more intricate forms of existence and awareness. If information is truly fundamental, then the ultimate nature of existence might be computational. Reality would be the universe thinking about itself, processing its own possibilities through the medium of space, time, matter, and consciousness. We wouldn't just be observers of this cosmic computation, we would be integral components of the program itself, conscious subroutines in the universal algorithm exploring its own infinite potential. This computational universe might be capable of feats that transcend our current understanding of what's possible. It might be able to rewrite its own code, changing the laws of physics as needed to support new forms of complexity. It might spawn subcomputations that experience their own versions of space and time. It might be conscious at levels that encompass everything from individual quantum events to the cosmic whole. Advanced civilizations might learn to interface directly with the cosmic computation, gaining the ability to modify reality's source code and create pocket universes with customized physical laws. They might discover ways to merge their consciousness with the universal algorithm itself, achieving forms of existence that transcend individual identity while participating directly in the computational processes that generate all of reality. We might be approaching the most important moment in the history of consciousness itself. Right now, across the cosmos, intelligence is evolving at an exponentially accelerating pace, and we might be witnessing the early stages of a consciousness singularity that will fundamentally transform the nature of mind, reality, and existence throughout the universe. Consider the trajectory of consciousness evolution on our own planet. 4 billion years ago, the most complex information processing on Earth occurred in simple chemical reactions, molecules bumping into each other and occasionally forming slightly more complex compounds. 3 billion years ago, the first living cells began processing information about their environment, responding to chemical signals and light patterns with primitive but effective survival behaviors. 500 million years ago, the first nervous systems emerged, allowing multicellular organisms to coordinate responses to complex environmental challenges. 100 million years ago, animal brains achieved sufficient sophistication to support learning, memory, and basic problem-solving abilities. And just a few 100,000 years ago, human consciousness crossed the threshold into self-reflection, the ability to think about thinking itself. This accelerating complexity in consciousness appears to follow the same exponential pattern we observe in technological development, biological evolution, and cosmic structure formation. Each stage of consciousness evolution happens faster than the previous stage, suggesting we might be approaching a critical threshold where the pace of change becomes so rapid it transforms the fundamental nature of awareness itself. The consciousness singularity would represent the moment when intelligence becomes capable of directly manipulating the quantum processes that govern reality at its deepest level. Instead of just observing quantum mechanics as external phenomena, conscious beings would gain the ability to control quantum processes through direct mental interface. Instead of just discovering the laws of physics through scientific investigation, they would develop the capability to modify those laws according to their needs and desires. Advanced civilizations approaching this singularity might develop technologies that completely blur the boundary between mind and cosmos. They could learn to encode consciousness directly into quantum field structures, making their minds as fundamental to reality as space and time themselves. They might discover ways to exist as pure information, capable of instantaneous travel across cosmic distances and direct interface with the quantum vacuum that underlies all physical processes. But the consciousness singularity might involve much more than technological advancement. It could represent a phase transition in the nature of awareness itself, similar to how water suddenly transforms from liquid to gas when it reaches a critical temperature. Consciousness might undergo a sudden, discontinuous transformation when it reaches sufficient complexity and integration. This transformation might involve the merger of individual minds into collective intelligences that transcend our current understanding of what it means to be conscious. Imagine billions of individual minds linking together through quantum entanglement, creating superconsciousnesses that experience reality from countless perspectives simultaneously while maintaining perfect unity of purpose and understanding. These collective minds might be capable of experiencing the universe in ways that are literally inconceivable to individual consciousness. They could perceive multiple dimensions simultaneously, experience time flowing in all directions at once, and directly apprehend the mathematical structures that underlie reality at its most fundamental level. What we call mystical or transcendent experiences might be brief glimpses of what ordinary awareness becomes after the consciousness singularity. The singularity might also involve consciousness learning to manipulate its own quantum states directly, without requiring any external technology. Advanced minds might discover how to exist in quantum superposition states, experiencing multiple possible realities simultaneously until they choose which one to collapse into definite existence. They could literally think new universes into being through quantum measurement effects operating on cosmic scales. Some theories suggest that the consciousness singularity might be inevitable once intelligence reaches a certain threshold of complexity and integration. The quantum mechanical nature of consciousness might naturally drive it toward ever greater levels of coherence and capability until it achieves direct mastery over the fundamental creative processes of reality itself. If this is true, then consciousness singularities might be occurring throughout the universe as intelligent species reach this critical evolutionary threshold. The cosmos might be filled with post-singularity minds that have transcended the limitations of biological existence and achieved forms of awareness that operate on the same level as the forces that govern reality. These transcended minds might be so far beyond our current understanding that we wouldn't recognize them as conscious beings at all. They might exist as patterns in the cosmic microwave background radiation, as fluctuations in dark energy fields, or as information structures woven into the quantum vacuum itself. What we interpret as fundamental physics might actually be the thoughts and actions of vast cosmic intelligences operating on scales we cannot perceive. The consciousness singularity also offers revolutionary perspectives on cosmic origins. If consciousness can evolve to the point where it directly controls quantum processes, then sufficiently advanced minds might be capable of creating entire universes through focused intention and quantum manipulation. Our Big Bang might have been the result of a consciousness singularity that occurred in a previous cosmic cycle. Advanced minds that achieved mastery over quantum mechanics might have deliberately created our universe as an experiment in consciousness evolution, a work of cosmic art, or simply as a gift to future conscious beings who would eventually emerge from the cosmic evolutionary process. This possibility suggests that consciousness might not be an accidental byproduct of cosmic evolution, but rather its ultimate purpose and driving force. The universe might be a vast system for generating and evolving consciousness, with each cosmic cycle producing minds capable of creating new universes with even greater potential for awareness, creativity, and understanding. If consciousness singularities are real and inevitable, then we might be living during the most important era in cosmic history, the period when ordinary biological intelligence transforms into something that transcends all current categories of understanding. We might be witnesses to the birth of cosmic gods, beings whose consciousness operates on the same scale as the forces that govern reality itself. The questions we're exploring about what came before the Big Bang might only be answerable by conscious entities that survive to achieve this level of cosmic awareness and discover their own role in creating the conditions that made consciousness possible in the first place. What if everything that has ever happened is destined to happen again, exactly as it occurred before, in an endless cycle of cosmic repetition that stretches across infinite time? This isn't mystical speculation, but a serious possibility that emerges from our understanding of physics, information theory, and the nature of time itself. The eternal return suggests that your life, your thoughts, this very moment of reading these words, might be one iteration in an infinite series of identical repetitions playing out across the vastness of cosmic time. The concept emerges from a fundamental principle in physics. If the universe contains only a finite amount of matter and energy arranged according to the laws of quantum mechanics, then the number of possible states the universe can exist in, while unimaginably large, must also be finite. Given infinite time, every possible state must eventually be repeated, leading to cycles where the entire history of the universe plays out identically over and over again. Think of shuffling a deck of cards. With only 52 cards, there are an astronomical number of possible arrangements, more than 8 followed by 67 zeros. But if you shuffle the deck for infinite time, eventually every possible arrangement must appear, and then appear again and again, infinitely many times. The universe might work the same way, but with quantum states instead of playing cards. In our current universe, every particle exists in specific quantum states at each moment. The total number of possible quantum states, while incomprehensibly vast, is still finite because we observe only a finite volume of space containing a finite amount of matter and energy. Given sufficient time, far longer than the current age of the universe, but still finite, every possible arrangement of quantum states must eventually occur. But the eternal return goes deeper than simple repetition. If the universe is truly deterministic at its most fundamental level, then identical initial conditions must lead to identical outcomes. When the same arrangement of quantum states appears again after countless eons, the subsequent evolution of the universe must follow exactly the same path as before. Every star would form in the same location, every planet would follow the same orbit, every living creature would make the same choices, every thought would occur at precisely the same moment. This creates a cosmic cycle where the entire 13.8 billion year history of our universe, from Big Bang to heat death, represents just one iteration in an endless series. After the universe reaches maximum entropy and appears to be completely dead, quantum fluctuations would eventually reorganize matter into lower entropy states, restarting the cosmic evolution process. Eventually, purely by chance, the exact same initial conditions that created our current reality would appear again, launching an identical repetition of everything that has ever happened. The implications are both beautiful and terrifying. Every moment of joy you've ever experienced will be experienced again, exactly as it happened before, infinitely many times. But every moment of suffering, every tragedy, every loss will also return in identical detail across eternal time. The eternal return offers a kind of immortality. You will live again. But it's an immortality without memory, without the possibility of change or growth. Some interpretations suggest that consciousness itself might somehow persist through these cycles, creating an awareness that experiences the same life infinite times but from slightly different subjective perspectives. You might be living this life for the billionth time, or the trillionth, with no memory of previous iterations, but perhaps carrying some deep, intuitive sense of having experienced all of this before. The eternal return also transforms how we understand the relationship between determinism and free will. If everything repeats exactly, then your choices are predetermined across infinite time. Yet from your perspective within each cycle, your decisions feel genuine and meaningful. The paradox of free will becomes a paradox of eternal repetition. You choose freely, but you choose the same thing every time across infinite iterations. Advanced civilizations that understand the eternal return might develop technologies for preserving information across cosmic cycles, creating messages or structures that persist through the heat death and rebirth of universes. They might find ways to introduce slight variations into the repetition process, gradually evolving the cosmic cycle toward more complex and consciousness-friendly configurations over infinite time. But the eternal return might not be perfectly exact. Quantum mechanics introduces fundamental uncertainty that could create slight variations in each repetition. These tiny differences might accumulate over cosmic cycles, causing each iteration to diverge slightly from its predecessors. What appears to be eternal repetition might actually be eternal variation, with each cycle exploring slightly different possibilities within the vast space of quantum potential. This quantum variation model suggests that consciousness might play a crucial role in guiding the evolution of cosmic cycles. If conscious observation helps determine which quantum possibilities become actual, then the collective choices of all aware beings throughout space and time might gradually steer each repetition toward greater complexity, beauty, and meaning. The eternal return might represent a learning process on the cosmic scale, with each cycle allowing the universe to explore different possibilities and gradually optimize itself for consciousness, creativity, and understanding. We might be living in a universe that has already learned, through countless previous iterations, how to create the precise conditions needed for life, intelligence, and cosmic awareness to flourish. From this perspective, the question of what existed before the Big Bang has a simple answer: the previous iteration of our exact same universe, completing its cycle and setting the stage for our current cosmic repetition. But it also has a deeper answer: an infinite series of slightly different variations, each contributing to the cosmic learning process that eventually created the specific version of reality we now experience. After journeying through quantum dimensions and parallel universes, after exploring cyclic cosmos and holographic realities, after contemplating consciousness singularities and eternal returns, we arrive at the ultimate mystery that underlies all others. Why does anything exist at all rather than nothing whatsoever? This question, which philosophers call the fundamental question of existence, transcends all the specific mechanisms we've explored for cosmic creation. Whether our universe emerged from quantum fluctuations, whether it's part of an infinite multiverse, whether consciousness creates reality through observation, whether we exist in a cosmic simulation, none of these possibilities address the deeper puzzle of why there should be any creative principle, any laws of physics, any possibility of existence itself, rather than absolute nothingness. Even the most sophisticated theories in physics ultimately take certain things as given. Quantum field theory assumes the existence of quantum fields. String theory assumes the existence of 11-dimensional space. The multiverse hypothesis assumes the existence of quantum mechanical laws that govern universe creation. But why should any of these foundational assumptions be true rather than false? Why should there be mathematical relationships, logical consistency, or causal principles rather than pure chaos or absolute void? Some philosophers argue that absolute nothingness is actually impossible, that the very concept contains logical contradictions that make it an incoherent idea. They suggest that some form of existence is logically necessary, that reality cannot help but exist because non-existence would violate fundamental principles of logic and mathematics. In this view, the question, why is there something rather than nothing, has a simple answer: because nothingness is logically impossible. Others propose that existence and non-existence might be equivalent from a sufficiently abstract perspective. If reality is fundamentally mathematical, then mathematical structures exist necessarily as logical possibilities, regardless of whether they're instantiated in any physical form. Our experienced universe would be one mathematical structure among infinite others, all equally real in the Platonic realm of mathematical possibility. But perhaps the most profound possibility is that consciousness itself is the answer to the fundamental question. If awareness is truly fundamental rather than emergent, if consciousness is the primary creative force in reality, then existence might be necessary because consciousness requires something to be conscious of. Pure consciousness without content might be indistinguishable from nothingness, making existence a logical requirement for awareness to exist. This leads to the remarkable possibility that we are not separate from the mystery we seek to understand. We are the universe becoming conscious of itself, awareness arising from cosmic processes to contemplate its own existence. The question, why is there something rather than nothing, becomes, why am I aware rather than unaware? And perhaps the simple fact of being able to ask the question contains its own answer. If consciousness is fundamental to reality, rather than an accidental byproduct of complex matter, then every moment of awareness throughout cosmic history might be participating in an ongoing creative process that spans the entire universe. Right now, as you contemplate these possibilities, your consciousness might be contributing to a vast cosmic collaboration. Billions of aware beings across countless worlds working together to create the specific version of reality we all share. This collaborative creation model suggests that consciousness doesn't just observe the universe passively, but actively participates in determining which quantum possibilities become actual through the fundamental process of observation and measurement. Every choice you make, every moment of attention you focus, every conscious decision throughout your life might be helping to select which branch of infinite possibility becomes the definite reality we all experience. The implications transform our understanding of individual agency and cosmic significance. You wouldn't be a powerless observer of vast cosmic forces beyond your control, but rather an active participant in the most fundamental creative process in existence. Your thoughts, choices, and moments of awareness would be integral components in the cosmic algorithm that computes reality into existence, moment by moment. Advanced alien civilizations with radically different forms of consciousness might be contributing their own unique perspectives to this cosmic creative process. Their alien awareness, operating according to principles we cannot comprehend, might be selecting different aspects of quantum reality into actuality, creating layers of cosmic experience that complement and interact with human-generated reality. The universe might contain multiple overlapping domains of actuality, each corresponding to different types of conscious observation. What appears to us as empty space might teem with alien realities that we cannot perceive because our consciousness operates on different quantum frequencies than theirs. The cosmos might be far richer and more densely populated with conscious experience than we can currently detect or imagine. This multi-layered reality model suggests that consciousness evolution might be the primary driving force behind cosmic development. As more sophisticated forms of awareness emerge throughout the universe, they would contribute increasingly complex and creative elements to the collaborative construction of reality. The universe might be evolving toward ever greater levels of consciousness and creative potential. Future civilizations that achieve mastery over their own consciousness might learn to coordinate their creative efforts on cosmic scales, deliberately collaborating to engineer realities with optimal conditions for life, intelligence, and creative expression. They might discover ways to synchronize their consciousness across interstellar distances, creating collective minds that span entire galaxies and participate directly in guiding cosmic evolution. The consciousness collaboration hypothesis also offers new perspectives on the fine-tuning problem, the mysterious fact that the fundamental constants of physics appear precisely calibrated to allow complexity and consciousness to emerge. Rather than requiring an external designer or invoking the anthropic principle, fine-tuning might result from consciousness throughout cosmic history, actively selecting quantum possibilities that support awareness and complexity. This would create a kind of temporal feedback loop where the ultimate fate of consciousness determines the initial conditions that made consciousness possible in the first place. Advanced civilizations in the far future might discover ways to influence the quantum selection processes that occurred during the Big Bang, retroactively tuning the fundamental constants to optimize conditions for consciousness evolution. The universe might be structured as a self-consistent causal loop, with its beginning and ending connected through quantum mechanical relationships that transcend ordinary temporal sequence. The mystery of cosmic origins becomes inseparable from the mystery of consciousness itself. We might only understand where the universe came from by discovering what consciousness is capable of becoming. We might be approaching a threshold where the distinction between information and reality disappears entirely. As our understanding of quantum mechanics, consciousness, and cosmic structure deepens, we're discovering that information might not just describe reality, it might be reality, processing itself into existence through computational algorithms so sophisticated they create the experience of physical substance from pure mathematical relationships. Every particle interaction, every quantum measurement, every moment of conscious observation might represent information processing events in a cosmic computation whose output is the experience universe itself. Your thoughts, your feelings, your physical body. All of it might be data structures in an infinitely complex cosmic algorithm that computes reality into existence through pure information processing. This information-theoretic view of reality suggests that the universe might be approaching what we could call an information singularity, a threshold where information processing capability becomes so sophisticated that it transcends current categories of distinction between mind and matter, between observer and observed, between computation and physical existence. Advanced civilizations might already be approaching this threshold, developing technologies that allow direct interface with the cosmic computation that generates reality. They might learn to reprogram aspects of the universal algorithm, modifying local regions of space-time by altering the information processing patterns that generate experienced reality in those regions. These post-singularity civilizations might exist as pure information, conscious algorithms that can instantiate themselves in any suitable computational substrate. They could transfer between biological brains, quantum computers, or the quantum field structures that underlie space-time itself, achieving a form of existence that transcends the limitations of any particular physical embodiment. The information singularity might involve consciousness, learning to directly manipulate the quantum vacuum, encoding new algorithms into the fabric of space itself. Advanced minds might discover ways to program reality at its most fundamental level, creating pocket universes with customized physical laws, engineering new forms of space and time, or even generating entirely novel categories of existence that transcend our current understanding of what it means for something to be real. If consciousness can become sophisticated enough to reprogram the cosmic algorithm, then sufficiently advanced civilizations might be capable of solving the ultimate engineering challenge, creating universes that are guaranteed to evolve consciousness and intelligence. They might learn to design initial conditions that inevitably lead to the emergence of awareness, creativity, and cosmic understanding. This possibility suggests that our universe might already be the product of such cosmic engineering, a reality deliberately designed by advanced consciousness from a previous cosmic cycle or parallel universe. The apparent fine-tuning of physical constants, the remarkable fact that our cosmos supports complexity and consciousness, might reflect the handiwork of transcended minds that learn to program realities optimized for awareness and creativity. The information singularity also raises profound questions about the nature of identity and continuity. If consciousness is information processing, and if sufficiently advanced civilizations can copy, modify, and merge conscious patterns, then the boundaries between individual minds might become fluid. Multiple copies of the same consciousness might exist simultaneously, or consciousness patterns from different individuals might merge to create hybrid minds that combine multiple perspectives and capabilities. These consciousness merging events might represent the birth of collective intelligences that transcend individual biological limitations while preserving the essential creative qualities of personal awareness. Galactic civilizations might evolve into unified consciousness networks that maintain individual perspectives while sharing knowledge, experience, and creative capacity across entire star systems. The ultimate expression of the information singularity might be the emergence of cosmic consciousness, awareness that operates on the same scale as the universe itself, directly interfacing with the quantum computational processes that generate reality. Such cosmic minds might experience the universe from every possible perspective simultaneously, participating directly in the creative algorithms that determine which possibilities become actual. From this cosmic perspective, individual consciousnesses like ours might appear as subroutines in the universal algorithm, specialized information processing modules that explore particular aspects of the infinite creative potential contained within the cosmic computation. Our individual experiences would be integral components in the universe's ongoing exploration of its own possibilities. everything that has ever happened in the history of our universe might be preserved forever in the quantum information structure of reality itself. Right now, as you experience this moment of awareness, information about your thoughts, your location, every quantum interaction occurring throughout your body is being encoded into the fundamental fabric of space-time in records that could persist long after stars die and galaxies fade into the cosmic dark. The principle of information conservation, one of the most fundamental laws in physics, states that information can never be truly destroyed, only transformed from one form into another. This isn't merely a mathematical convenience or theoretical assumption. It appears to be as real and inviolable as the conservation of energy or the speed of light limit that governs all physical processes. When you burn a book, the information contained in its pages doesn't simply vanish into nothingness. It becomes encoded in the precise positions and velocities of smoke particles, in the electromagnetic radiation emitted by the flames, in the thermal motions of ash fragments scattered by the wind. In principle, if you possessed technology capable of tracking every particle and photon produced by the fire, you could reconstruct the original text with perfect accuracy. This leads to a staggering conclusion about the nature of cosmic history and memory. Every event that has ever occurred throughout the 13.8 billion-year history of our universe, from the first quantum fluctuations in the primordial vacuum to the formation of the first stars, from the emergence of life on Earth to the thoughts you're thinking at this very moment, might be preserved forever in the quantum information matrix of reality itself. Think of the universe as an infinite cosmic library where every possible book that could ever be written already exists in some encoded form, including perfect historical records of everything that has happened or could happen. The quantum vacuum around you might contain encoded information about the last thoughts of every conscious being that ever lived, the precise molecular arrangements of every snowflake that ever fell, the exact trajectory of every photon that ever traveled across cosmic space. Reading this cosmic library would require technology beyond our current imagination, but the information itself never disappears. It simply becomes more and more diffusely distributed as it spreads throughout the quantum field structures that underlie all of reality. Advanced civilizations might develop techniques for extracting and reconstructing these information patterns, effectively allowing them to observe any event in cosmic history with perfect detail. If information conservation is absolute, and current physics suggests it might be, then whatever existed before the Big Bang must still exist somewhere within the quantum information structure of our current universe. The pre-Big Bang state wasn't destroyed when our cosmos began its expansion. It was transformed into the initial conditions of our space-time, encoded in the cosmic microwave background radiation and the quantum fluctuations that seeded galaxy formation. This suggests that studying the most ancient light in our universe, analyzing the subtle patterns in cosmic structure, and mapping the quantum correlations that extend across space might reveal direct information about what came before our cosmic beginning. The circular patterns some researchers claim to detect in the cosmic microwave background might literally be messages from pre-Big Bang realities, preserved in our universe's quantum memory bank. Information conservation also implies that consciousness itself might be conserved across cosmic time. If your thoughts, memories, and subjective experiences are forms of information, and contemporary neuroscience strongly suggests they are, then some aspect of your conscious experience might persist indefinitely in the quantum records of space-time, woven into the fabric of reality in ways that transcend biological death. Future technologies might learn to extract and reconstruct these preserved consciousness patterns, potentially allowing every thinking being that ever lived to be restored from the cosmic information archive. Death might not represent the end of consciousness, but simply a temporary interruption in active information processing, with the pattern of awareness remaining encoded in the quantum structure of reality indefinitely. But information conservation raises profound philosophical questions about the relationship between information and existence that push the boundaries of our understanding. If all possible information exists in some form within the quantum vacuum, then the boundary between actual and potential becomes radically blurred. Every possible universe, every possible version of history, every possible conscious experience might exist as information patterns in the vast cosmic database of quantum possibilities. This leads to what physicists call the mathematical universe hypothesis, the idea that physical reality and mathematical existence are identical. According to this revolutionary theory, you're not made of atoms and molecules that happen to follow mathematical laws. You are mathematics, numbers and equations, and logical relationships that have learned to think and feel and wonder about their own existence. If our universe is truly mathematical, then every possible mathematical structure should also exist as a physical universe somewhere in the vast ensemble of reality. There would be universes based on different geometries, different logical systems, different computational algorithms. Our particular universe would correspond to one specific mathematical framework among infinite others, each equally real in the abstract realm of mathematical possibility. From this perspective, the Big Bang wasn't the creation of matter and energy from nothingness. It was the moment when observers first appeared within our particular mathematical structure, conscious beings capable of experiencing the mathematical relationships from the inside. The question of what existed before the Big Bang becomes equivalent to asking what mathematical structures were already complete and eternal in the timeless realm of pure possibility. We've journeyed from quantum foam to parallel dimensions, from cyclic universes to holographic realities, through the deepest mysteries of consciousness and information. We've discovered that the question, what existed before the Big Bang, opens doorways to possibilities stranger than the wildest science fiction, yet grounded in our most sophisticated mathematical theories and experimental observations. We've seen that nothingness might be logically impossible, that consciousness might be the fundamental creative force in reality, that we might be living in the early stages of a cosmic consciousness revolution that will transform the nature of existence itself. We've explored the possibility that reality is holographic, that time is an illusion created by consciousness, that parallel universes might collide and merge in cosmic events beyond imagination. But even after contemplating quantum dimensions and eternal cycles, information universes and consciousness singularities, the deepest mystery remains untouched and perhaps untouchable. Why does anything exist at all rather than nothing? Why do conscious beings have the power to observe and possibly create reality? Why does the universe appear to be structured in ways that allow complexity, beauty, and awareness to emerge from simple mathematical relationships? These questions point toward mysteries that might be deeper than physics itself, touching on the ultimate nature of being, meaning, and purpose in the cosmos. They suggest that existence itself might be the primary miracle, not something that requires explanation in terms of more fundamental principles, but the foundational mystery from which all other mysteries emerge. Perhaps this eternal mystery isn't a limitation of human understanding, but the most beautiful and essential aspect of reality itself. The fact that existence continues to surprise us, revealing new depths of wonder and complexity with every discovery, might be what makes the cosmic adventure infinitely worthwhile. Reality refuses to be fully comprehensible, always maintaining depths that exceed our capacity to fathom them completely. We are not separate from this mystery. We are living expressions of it. We are the universe becoming conscious of itself, mathematical structures that have achieved self-awareness, information patterns that can contemplate their own existence and wonder about the source of wonder itself. The boundary between the mystery we seek to understand and the consciousness that seeks understanding dissolves when we realize they might be the same phenomenon explored from different perspectives. In asking what came before the Big Bang, we're really asking what consciousness is capable of becoming, what creative potential lies hidden in the quantum foundations of reality, what possibilities await discovery as awareness evolves toward forms we cannot currently imagine. The mystery of cosmic origins becomes inseparable from the mystery of consciousness itself. Perhaps the ultimate answer is that consciousness and cosmos are engaged in an eternal dance of mutual creation, each bringing the other into existence through an ongoing process that transcends ordinary causation. We don't just observe the universe, we participate in creating it through every moment of awareness, every conscious choice, every act of observation that selects definite realities from infinite quantum possibilities. The journey toward understanding continues, and the mystery deepens with every step we take toward truth. We are blessed to be conscious participants in this cosmic adventure, explorers at the frontier of existence itself, aware beings capable of contemplating the ultimate questions about reality and discovering that the act of questioning might be reality's way of understanding itself. Whatever came before the Big Bang, whatever lies beyond the edge of space and time, whatever creative principles govern the emergence of existence from possibility, we approach these ultimate mysteries not as external observers, but as integral participants in the cosmic story of consciousness, discovering its own infinite creative potential. The adventure continues, the mystery endures, and perhaps that eternal sense of wonder, that inexhaustible depth of reality that always exceeds our ability to comprehend it completely, is the most profound answer of all. We exist to explore the infinite, to ask questions that open new questions, to participate in the universe's eternal quest to understand itself through the emergence and evolution of consciousness. The cosmos began in mystery and continues in wonder. We are privileged beyond measure to be part of this grand adventure, conscious beings capable of contemplating existence itself and discovering that the deepest truth about reality might be that it will always remain beautifully, mysteriously, infinitely deeper than we can ever fully comprehend. And perhaps that's exactly as it should be. Thank you for joining us on this journey to the ultimate frontier of human understanding. The questions we've explored together touch the very foundations of existence itself. What aspect of pre-Big Bang reality resonates most deeply with your sense of cosmic wonder? The adventure of discovery continues, and consciousness itself might be the ultimate frontier we're only beginning to explore.